right, so we left off with complete the square on number 3 in your notes. Okay, so number 3, I have 18x plus 3x squared equals 45. And I told you that you need to get it in the form x squared plus bx equals c. So I need a 1x squared. I can't have a number for my x squared. So I'm going to get all my x's on one side. So 3x squared plus 18x equals 45. And I'm going to divide by 3. So I divide by 3, divide by 3. Have we done this one?
No.
No, okay. So I get x squared plus 6x equals 15. Okay, now it's set up in that form so I can complete the square. So I'm going to do what I call halving it and squaring it. So I'm going to divide my b value by 2. So I'm going to take b divided by 2 squared. All right, so I get 6 over 2 squared is 3. So when I square it, I get 9. Okay, and that's going to be what I add to both sides of the equation. So I'm going to have x squared plus 6x plus 9 equals 15 plus 9. All right, so the whole reason I did this is so I can complete the square. So it makes this left side of the equation into something quantity squared, like something times itself. So if you factor, you can see that you have x plus 3 times itself, x plus 3. So I'm going to write x plus 3 squared equals 15 plus 9, so 24. So I'm ready to take the square root of both sides. So square root, right, plus or minus. So I end up getting x plus 3 equals plus or minus the square root of 24. Okay, and 24 breaks down. So something that's a factor of 24 that I can take the square root of is 4. So it's going to break down into square root of 4 and square root of 6. So square root of 4 is 2, square root of 6 stays how it is. And then my last step, I want to solve for x, so I just subtract 3 over. So I'm going to have x equals negative 3 plus or minus 2 root 6. And that's your answer. You can't combine any further because if I had negative 3 plus 2 root 6 or negative 3 minus 2 root 6, those are my two answers. This square root part is treated like an x. So if I had negative 3 plus 2x, I wouldn't be able to combine those and say negative 1x, right? So same reasoning with the square roots. You can't combine them any further. Okay, so this next one, I just need to add the 4 over. So I get all the x's on one side. And in this case, I do have 1x squared. So that's good. Okay, so, oh, I did do 4? Did I do 4 here? Okay, so I did this one. Okay, so let's do this one then. So 5. So I have x squared minus 4x equals negative 6. So I'm going to do my b over 2 squared. So I get negative 4 over 2 squared is negative 2 squared, so I get 4. Okay, once you do that, that's the number that you add to both sides of your equation. So I'm going to get x squared minus 4x plus 4 equals negative 6 plus 4. So I added it to both sides. You don't need to put it in the box. I just did it so you guys can see it. All right, so that factors. So the left side is going to factor into x minus 2 times itself, x minus 2. And the right side is just going to combine to be negative 2. So I have x minus 2 quantity squared equals negative 2. Okay, this is going to be one that has an I answer because my next step is I'm going to take the square root of both sides and I have the square root of a negative. So I'm going to do square root. I write plus or minus when I take the square root. So I have x minus 2 equals plus or minus the square root of negative 2. Now square root of negative 2, I really think of it as square root of negative 1 times square root of 2. And square root of negative 1, we learned in the last chapter, is I. So it's going to be I root 2. So I'm going to have I root 2 here. All right, and then I'm just going to add the 2 over. So I get x equals 2 plus or minus I root 2. And that's your solution. So 2 plus or minus I root 2. Okay, the next one. So get the x's on one side. So I have 3x squared minus 6x equals 10. I divide by 3 on both sides. So the x's work nicely. I get x squared minus 2x. But over here I do have a fraction, 10/3. So I complete the square, so I do the b divided by 2 square. So b over 2 squared. So I get negative 2 divided by 2 squared is negative 1 squared, which is 1. So that's going to be what I add on both sides of the equation. So I'm going to have x squared minus 2x plus 1 equals 10/3 plus 1. So I keep my equation balanced. Whatever I do to one side, I do to both sides. The left side, x squared minus 2x plus 1, factors into x minus 1 times itself, x minus 1. Do you guys see that this number that goes right here, this negative 1, do you guys see that that's the number you had before you squared? That's always the case. See how I had negative 2? That was the number I had before I squared. So you can kind of check your work as you're going. I had 3. That was the number I had before I squared. Okay, it's always that number. All right. So I have equals 10/3 plus 1. So it's going to be 10/3 plus 3 over 3. So I'm going to get 13/3. So 13 over 3. I take the square root of both sides. I write plus or minus. So I get x minus 1 equals plus or minus the square root of 13 over the square root of 3. So I bring the square root in both pieces. Right, I'm going to add 1 over, so I get x equals 1 plus or minus the square root of 13 over the square root of 3. But I don't want the square root of 13 over the square root of 3. What do I need to do to that? Okay, I can't have square roots on the denominator, so I need to multiply by what? Square root of 3 on top and bottom. So I'm going to multiply by square root of 3 over square root of 3. So I get x equals 1 plus or minus the square root of 39 all over 3. Okay, and you can leave your answer like that. Now when we do quadratic formula eventually, you're going to have another answer. It's going to look like x equals 3 plus or minus the square root of 39 all over 3, which is fine. All we did here is we got common denominators with this 1. So I wrote it as 3 over 3, and then I combined. So you could have a different form. And it's good to recognize those other forms, because if you were doing like a multiple choice test or something like SAT, ACT, knowing how to get those different forms is always good. Okay, so whenever things work out nicely with no square roots, no i's, just fractions, like if you had answers of 1/2 and 5, or -3/5 and 2, right? Those are ones that like originally you could have factored. But complete the square is really nice because it solves things that don't factor as well. So it gives you I answers and square root answers as well. So I like complete the square because it solves every single one. All right, so this next one. So I have 8x squared plus 4x equals 12. So I'm going to divide by 8 everywhere. So I'm going to get x squared plus 1/2 x equals 12 over 8 is divisible by 4 on top and bottom. So I'm going to get 3 over 2. So get that. Now it's in that form that I want where I have 1x squared, x's are on one side. So I'm going to do my b over 2 squared. So b divided by 2 squared. So I'm going to have 1/2 divided by 2. So I'm going to write it like this, divided by 2 squared. So that way I see it's 1/2 times the reciprocal of 2. So times 1 over 2 squared, which is 1/4 squared, which is 1 over 16. So I get 1 over 16. So I'm going to have x squared plus 1 over 2x plus, I add the 1 over 16 to both sides. So whatever I do to one side, I do to both sides. Okay, and I've already given you a hint. It especially works for these fraction ones, that when you factor into something squared, that last number is what you had before you squared it. So it's the b over 2. So it's going to be 1/4. So I'm going to have x plus 1/4 quantity squared. Does that make sense why it would have to be that? Because when you write it next to itself, the 1/4 and 1/4 are multiplying to be the 1 over 16, right? They're squaring to get that. And then when you look at your outer and inner swoops, 1/4 x plus 1/4 x, that ends up being the 1/2 x. So it works out. All right, so then I get equals 3 over 2 plus 1 over 16, so I need to get common denominators. So I'm going to have 24 over 16 when I multiply by 8 over 8 and 1 over 16. So I end up getting 25 over 16. All right, so I'm ready to square root both sides. So take the square root of both sides, plus or minus. And this one works out pretty nice because I have the square root of 25, which is 5, and the square root of 16, which is 4. So I'm getting x plus 1/4 equals plus or minus 5/4. And then I subtract my 1/4 over, so I get x equals negative 1/4 plus or minus 5/4. And that's two answers. So the first one is negative 1/4 plus 5/4, and the second one's negative 1/4 minus 5/4. So negative 1/4 plus 5/4 is going to be 4/4, which is 1. And the other one is negative 1/4 minus 5/4, which is negative 6/4, which reduces down to negative 3 over 2. So those are your two answers. So negative 3 over 2 and 1 are your answers. So that's one where originally, if you had tried to factor, it would have worked. So you don't have to write this, but let me show you quickly that if I started from the original and I tried to factor, I'd have 8x squared plus 4x. I'd subtract the 12 over, because I need it set equal to 0 when I factor. I pull out a common factor, right? And then I factor with my two sets of parentheses, so 2x and x. I would need 3 and 1 to combine to be 3x and 2x make 1x if I have positive 3 and negative 1. Right, and then that would be how it would factor. So if you set each piece equal to 0, 2x plus 3 equals 0 gives you negative 3 over 2. And x minus 1 equals 0 gives you 1. So it's much, much faster to factor. So I always try factoring first, and then I do complete the square if it doesn't work. Okay. So, but on your homework, obviously, you'll just do complete the square because it's kind of learning the method, right? All right, so this next one, so I have 6x squared minus 4x equals 1. So I'm going to divide by 6 everywhere. So I get x squared minus 4 over 6 is 2/3, so 2/3 x equals 1 over 6. And now I'm ready to do the b over 2 squared. So I'm going to take my number and divide by 2 and square it. So when I have a fraction, I always write like my divided by 2 like that. It's called an obolus. All right, so I'm going to use that old school division sign. All right, which means I have negative 2/3 times 1 over 2. So those 2's actually end up canceling. So I'm going to get negative 1/3 and then squared. So 2's are gone. So negative 1/3 squared is 1/9. So I'm going to add 1/9 to both sides. So I'm going to have x squared minus 2/3 x plus 1/9 equals 1/6 plus 1/9. Okay, so it factors into x minus 1/3 times x minus 1/3, so x minus 1/3 squared. Then I have to get common denominators on the right side. So I have 1/6 plus 1/9, so I can make them both 18 on the denominator. So it's going to be 3 over 18 plus 2 over 18, so I get 5 over 18. I can already tell this one's going to be messy. Do you guys see why it's messy? I'm going to take the square root, and I have the square root of 5 over 18, which is gross. All right, so I'm going to do square root of both sides. So square root, plus or minus. So I get x minus 1/3 equals plus or minus the square root of 5 over 18. So square root of 5 I leave. What about square root of 18? It's on the bottom. So you could multiply by square root of 18 over itself to rationalize it, but let's actually simplify first. So square root of 18 is 3 radical 2, right? Square root of 9 times square root of 2, square root of 9 is 3. So I don't need to multiply by square root of 18. I can actually go smaller. So I'm going to multiply by square root of 2 on top and bottom. So I get x minus 1/3 equals plus or minus, I'm going to have the square root of 10 on top now. And then I have 3 times radical 2, radical 2. So those two radical 2's, so radical 2 times radical 2 is going to be square root of 4, which gives me 2. So I have 3 times 2, which is 6. It's a lot of computing. All right, and then add the 1/3 over. So I get x equals 1/3 plus or minus radical 10 over 6. And that's your answer. So 1/3 plus or minus root 10 over 6. So what if you did have common denominators? Then you might see x equals 2 plus or minus root 10 all over 6, right? Because you could rewrite 1/3 as 2 over 6 and then combine them. So just know kind of, oh yeah, it could also be in this form. All right, you guys try the next two. So I'll walk around and help. So try the next two. All right, so I saw a lot of correct answers as I was walking around. So you're going to have x squared plus 6x equals -1 to begin with. So you have all the x's on one side, all the numbers on the other side. Now you do your b over 2 squared. So in this case, it's 6 divided by 2 squared. So I get 3 squared, which is 9. Okay, and I saw you guys add that to both sides. So 6x plus 9 equals -1 plus 9. All right, and then you factored, so you saw it was x plus 3 times itself, so x plus 3 squared. And then you had 8, and you took the square root of both sides and wrote plus or minus. So you had x plus 3 equals plus or minus, and you can reduce down square root of 8, so that's going to be 2 radical 2, 2 root 2. Right, because it's square root of 4 to square root of 2, so 2 root 2. All right, and then subtract the 3 over. So you get x equals -3 plus or minus 2 root 2. And that's your answer. Do you guys get it? All right, next one's a lot harder. So you're going to have the 2, I kind of write it over here. So you're going to have your 2x squared minus 4x, and then you subtract the 5 over. So you divide by 2 on both sides. So you get x squared minus 2x equals -5 over 2. All right, you're going to do your b over 2 squared. So you take that number, you take -2 divided by 2, and you square it. So -1 squared, so you get 1. And you add it into both sides. So you're going to have x squared minus 2x plus 1 equals -5 over 2 plus 1. And you factor, so it factors into x minus 1 times x minus 1. So you can write that stuff if you need to see it. But it should be a perfect square. It should be something times itself. That's why it's called completing the square. We made it so it was a perfect square. All right, and then over here I get -5 over 2 plus 1. So if I had common denominators, it'd be 2 over 2 and -5 over 2. So it's going to be -3 over 2. And then I take the square root of both sides. Square root, plus or minus. So I get x minus 1 equals plus or minus the square root of -3. So I don't like seeing square root of -3, so instead I'm going to write I root 3. Right, square root of -1 times square root of 3. All over square root of 2. So this is kind of involving like all the things you'd possibly have to do. It's involving fractions, it's involving square roots, it's involving i's. This is as hard as it's going to get. Okay, so if I have square root of 3 over square root of 2, I don't like that square root of 2 on the denominator. So I'm going to multiply by square root of 2 over itself. So on top, I get plus or minus I root 6. And then on the bottom, I get square root of 2 times square root of 2, which doesn't just cancel out. It's not 1. It's square root of 2 times square root of 2 is 2, right? Square root of 4, which is 2. All right, and then I add the 1 over. So I get x equals 1 plus or minus I root 6 all over 2. Or you could have 2 plus or minus I root 6. Big line for your fraction all over 2. That's fine. So I could write that one out. 2 plus or minus I root 6 all over 2. So either way, I don't care which form you write. Yeah, Jenny.
So how did you get the I?
Because it was the square root of -3. So I think of it as square root of -1 times square root of 3. And square root of -1, if you remember from last chapter, that's I. So I root 3. Yeah. It's frustrating with algebra. Everything builds on itself. You got to remember everything. But I think you'll see when you guys review for the final, you'll be like, oh yeah, I know how to do all this. Because you've been doing it this entire semester, you know. So you'll kind of remember all that stuff. All right, so let's play our game.